All right. So let's talk a little bit about the homework for today. Then I want to kind of finish up our discussion from last time with Swift and things like that. We'll talk a little bit about the final exam, but I'll be intentionally misleading and make it sound like it's significantly harder than it actually. It'll probably be impossible. So, because if I have a goal, it's to make sure you leave today completely stressed out. Yeah, and almost making yourself sick until the final next week. So, I mean, if there's pictures involving that, then that's only going to benefit you. Yeah.
Is this one in class?
Well, I haven't talked about it yet. No, it'll be online.
You should have a bonus pop quiz saying how many things have we put into the insurance.
Yeah, maybe that'll be a sad thing. Maybe there'll be a question on the exam about the things that V has put in my drink, and then what's bad is I bet you the Ann Arbor folks do better on it. They probably would.
What we got so far? We got Cheerios.
No, it's Cocoa Puffs, wasn't it?
We had Cocoa Puffs, we had chia seeds, we had pepper,
And then
we had various fruits.
There was a
Cucumber, we've had cucumber in there. I want to say I had a carrot at some point. Did I have a carrot?
Did you have a carrot?
I don't
You
remember
do
being
have
like
a
3 or 4
spinach
classes.
and
Wait, there was spinach, right? Or like what?
Oh, there was a spinach. There was spinach once.
These are all suspiciously things from the salad bar, which is right next to the soda machine.
Right.
Well, I mean, it makes sense then, because it'd be quick
You have any
access.
cheese? Any ghost cheese in there?
Don't give her any ideas. There's not been cheese in there yet.
Nice little chunkies. Let's go down and drink it.
Soup in there. That'd be a whole
You can even throw in the
Coffee with blue cheese crumbles.
Yes.
Oh, God. No.
Maybe just
At
make
least
the
it's
blue
been
cheese crumble.
consistently Mountain Dew so far.
Yeah, I'm just. Oh, then there was one time she put lemonade in with the soda, just mixed it.
Oh, that's right.
And gave you sugar.
Huh?
And gave you sugar.
Give me sugar, and I can't have sugar.
You try to poison him.
Seriously.
I put Blaine in there too the other day.
You put
Blaine's
Blaine in there? What? I had
What did you-
like Blaine's head hairs or something?
Where'd you get my hair from?
stuff. No, like Blaine stuff.
What?
What is going on?
I feel like we've maybe taken this conversation as far as we should. I feel like we need to hit the wall when we hit the thing with Blaine's stuff. Oh yeah, we had a Hershey's Kiss in it one time that apparently was your candy.
Gotcha.
I see.
Okay. I still don't get what you're calling that. Blaine's top? What
Blaine's
Hershey's
stuff.
Kiss?
Blaine's stuff. Which really could take us in all sorts
Yeah,
of
I know. I was like,
directions we should not have on recording. All right, so we talked about, you guys looked into uses of C today compared to other languages. What do we think? Where is C used today compared to other languages? Go ahead.
Basically, it's super useful for embedded systems and operating systems and such. Low-level resource management.
Okay. What makes it super useful? Who?
It's robust.
Robust. Oh, what does that word mean?
Like you can use it for like specific. I don't know if that was the right word, but
You just wanted to say it?
Yes.
It just felt like a good word to say. Something I've been practicing that in interviews. Like, I feel like I'm a robust candidate.
oh, really?
Okay.
Okay.
And,
I go in with a more appropriate term. I am a rotund candidate.
but this is you have control over like memory power a lot easier than like something like Java.
Okay, so maybe less constraints, less things are in your way.
Yes.
Okay, what were you gonna say, Sam?
Oh, like I read, like, when I was doing some research, it's this website says it's like a middle level language, so it can talk to low level languages and high level languages.
Okay.
So kind of you can do both things, so you can like kind of just kind of everywhere. Today.
So maybe that actually has something to do with its use in operating systems where you can use it for communication or interfacing between like maybe a user level application that's already written, as well as the Core OS API or something like that. Anything else we found? Good.
its libraries have been like updated for
Okay, so maybe stability.
Yeah.
We've had a lot of eyes on it for a lot of time, and maybe some of the obvious major issues have probably been worked out.
Yeah, and it's sort of similar to Cobalt in the same way that it's been around for so long that companies wouldn't want to update their.
Okay, yeah. So part of it is just budget, right?
Yeah.
You know, where you have companies that maybe have lots of libraries already written in C, and even if they were starting fresh that day, if they would choose a different technology, the cost to switch over to something else from their existing tool that works is too much. It actually becomes an interesting economics problem at a lot of businesses. Take like a Northwestern Mutual or something like that, just as an example. So this is a company that has a lot of, older COBOL code and things like that. And on a given year, companies like this, a department might get a budget, right? And that budget is probably a big number compared, what we might think is a lot of money. But that number might not be enough to really make a dent in transferring stuff over. So they would rather invest, effectively lose money over time. So maybe it's $10 million to make the switch, just using a number. But they can only spend $2 million a year. So they'd rather spend $2 million for 20 years, $2 million per year for 20 years, than spend $10 million once and save money for the rest of the time. Yeah.
It's rather visible in the respect that you know what's going on with the code. It's what it's. There's nothing going on behind the scenes like you might have in Java or C# where you create something and it's doing all that magic for you with your objects.
Yeah.
You do something, you have to explicitly tell it this is what it's doing, and you have a lot of control over that.
Yeah, so some of the things we talked about last time, and we're going to be talking about here with Swift today, that have kind of evolved in languages over the time where, there's certain syntax or certain things that you always write a certain way that they now start taking, in our modern languages, start peeling some of that syntax out as a convenience to the programmer. That stuff is still in for C. Now, why is that a good thing? Or why might that be a good thing? You're suggesting maybe the code is easier to read by a technical person.
Right, so somebody who is very familiar with it would know exactly what's going on with it.
Yeah, because there's less maybe little hidden costs,
Right.
hidden bells and hidden things. Similarly, I think a big thing is going to be the direct dealing with memory. And that's really its connection with operating systems pretty strongly. Anything else? Go ahead.
It's really fast compared to like Java. Even just like different programs that I've written, like same exact algorithm in Java and C, like the C1 will run like significantly faster.
Okay. Noticeable to a human faster?
Yeah.
Or when you run it through like the time command?
It's something where like the thing would take, 5 seconds or so it would be noticeable.
I got you. So it takes a half a second in C and it takes 5 seconds in Java, and then you notice you notice that at that point.
Yeah.
It's not a life-changing problem, but it's a noticeable difference.
Yeah, definitely.
I mean, that might also be because Java's running on the virtual machine, and with C, you're just going straight to memory. You're just accessing it directly, so it's.
So why are you leaving the wiggle room in there that it just might be that?
I don't know. I guess it would be that. I mean, there could be other factors that are playing into Java running slower, but that would be my assumption.
Yeah, so I mean, the idea that it's running on a virtual machine definitely has to do with its. If there's any sluggishness, let's start right there with the idea that you're something running inside of something else that's running on top of an operating system.
My question is, would we have the same results running it through like Python or something that isn't running through a virtual machine?
You'd have similar results because still Python is running through an interpreter.
Sure.
Yeah, so Python's an interpreted language versus C being a compiled language, right? So anytime you're talking about speed, compiled languages are going to be faster than interpreted language. Now, an interesting comparison would be Python versus Java. Because now you have a compiled language running in a virtual machine versus an interpreted language running on top of an interpreter, right? But not running in a virtual machine, unless you're doing some web stuff with Python and running it in some kind of web container or something. But even that's more of an organizational tool, not a translation tool. So that might be a more interesting race. My gut feeling is that for things where Java doesn't need to jump to weird constraint objects, Java would probably still win over Python. Python is used for so many things like in data science and machine learning, really for one thing is there's so many resources out there and a lot of people have gotten used to using the syntax. And I think because of that, the gap that's trying to be closed between data science and let's call it machine learning and the people who are doing that stuff aren't always computer science people. So a lot of them, they're more of, so like the data science people might be like accountants or actuaries. You know, these are people that are looking at data pretty often and making decisions. They might even be, analysts for a business. And historically, they've had to use third-party tools to visualize their data or something like that. And now they're the ones that are, leveraging these maybe more flexible tools at the cost of having to do some programming, maybe, right? And so a language that has maybe a lower entry point, like Python, is preferred over, we'll go in the other extreme and say like C. Right, C, when you go, you got to compile it, and you got to know what architecture you're targeting, and you have to choose what your output file is going to be called. The default C compiler on Unix gives you a file called a.out. That's your executable. So you'd have to purposely rename that or whatever. You can link in other libraries, but you have to do that also from the command line. So there's a lower bar there. Yeah.
In my research, I found that C is most commonly a starter language for programmers. Why is that?
I think that is not a true statement today. Now, having said that, it is not unfounded. I've seen it before, and it's actually an interesting question. So most of you in here, well, how many of you in here have worked with C at this point? So most of you now, and that's really something that's come out of for most of you, was that in 350?
Yeah.
Okay, that was your first opportunity working in C, and that's a good thing. So that's already an improvement there. We're going to start doing C++ in the 300 class starting next semester. So you take C as your first language. Let's assume that you had C in the 200 class. How would that have played out? What do you think? The good, the bad, the ugly. Would that have been a good starter language?
I think some people would have dropped right there.
Huh?
I think some people would have dropped right there.
Would you have dropped right there?
No.
Oh, so we kind of missed the boat.
Yeah.
Ha!
Low levels.
Just take
Um, what's good about C? If C was the first language, what might be good about it?
You really have to think about passing by value versus passing by reference, and just the idea of like working with memory.
So if you start thinking about some of the things, I think most of you had me for your programming sequence, right? You think about some of the things over those years that I really, really, really emphasized. How many times do we talk about pass by value versus pass by reference? And sometimes those things are hard to show in a language like Java. You have to almost show by example, right? You write a function, you pass an object to it, you change it in there, and you see that the change was permanent. It happened outside of it. You pass an array to it and see that it was passed by address. And then you pass an integer to it, int a equals 5. You pass it in there, you change it, print out to see the change. Then when it's done, you print it out again and see that it's still 5. Passed by value, right? So you have to see it as the example. Where in a a language like C, you have to be more explicit with your syntax. You don't have to be explicit with primitive types, with integers. If you pass an int in, and the default behavior is you change it, it won't change. It's passed by value is the default behavior. But you have the ability in C to pass an int in by address. You could say, hey, here's a memory address. You start making changes to this dude, it's going to be felt somewhere else. You have the option to do that, so you have some additional flexibility. Is that good for a beginning programmer? Or are we throwing too many balls at him at once? You can go either way. On one hand, you got trial by fire, right? And on the other hand, you have, you kind of giving them a little step. The tough thing is it's probably, I think the trial by fire might work better for the programmers or for the students that maybe have a little bit more either natural ability or their mind already kind of works that way, something like that, because I think that would make them feel uncomfortable sooner. Because otherwise, I think what ends up happening is like the first half of a class like 200 becomes pretty boring for some of those students, where if you can get them uncomfortable week 2, that's better for them. But then the risk is you leave everybody else behind because they're way more than uncomfortable, right?
Yeah.
They might as well be taking one of the Greek Bible classes. It doesn't matter that they're learning C, it's the same thing as Greek.
Pointer type of
Yeah.
I was gonna say, another thing that might come out of having C as your first language, it kind of goes with memory, but like, somebody might be more conscious of garbage collection, which isn't necessarily a bad thing, but we don't think about that a lot of times because it just is automatically done.
Yeah. So historically, in real life, and this is kind of a crossover, right? So in real life, we're in charge of cleaning up our own messes, or we're supposed to be, right? We don't clean up our room, somebody yells at us. Clean up your room. I assume that probably happens in dorm rooms. Sometimes you have the one roommate who's the neat freak, and all the other roommates are slobs. And I see like people looking at each other now. So I'm guessing. Okay, so we've started a fight. So we're gonna take bets again. Hey, all right. So this is Luke versus Austin. Okay, we're gonna duct tape their hands behind their back. You're only allowed to use faces. Go.
I feel like I'm at a size disadvantage here. I got headbutted into the wall.
Use your meme knowledge. Throw insults out like the French.
Yeah. So in real life, we're in charge of cleaning up our own messes, right? And if we leave too many things piled around, things start getting cluttered, right? There's only so much space in your dorm room before it starts bothering you, right? We all have different. We all have different tolerances. Yeah. So for any of you who've ever been in my car, because I have a big SUV, but rarely do I have other people in the car with me, or it's just one other person in the front seat. But I need a big car because you notice I'm a big guy. So, but I'm always having protein shakes or a soda or whatever. And so as soon as I'm done with it, I just throw it behind my seat. I don't put like rotten food and stuff back there. It's always, empty water bottles and stuff like that. But to the point where, it fills up back there. And so the only time I have to think about it is when like other people come and get in the car. So whenever V rides in the car, it's her job to bring a garbage bag with her to clean out the back of the car. And I think Blade made the comment a couple weeks ago. It's like, oh, do you only clean out your car, or does your car only get cleaned out when you like trade it in? Because I get new cars pretty often too. So like, I probably could make it between. For the video, V is actually showing Blaine a picture of her with the garbage bag.
No, it was you.
Well, you just had me pose with the garbage bag, but you're the one who filled it.
I thought it was just a show off your coat.
Oh, yeah.
No, it's a whole one of trash.
It's a Chinese coat.
So is V your automatic garbage collection?
V is my automatic garbage collection. Exactly. Okay, so, the idea is we have different tolerances, but eventually, for all of us, right, we hit our limit. So for our normal computers, it's when you run out of RAM, right? You got so much RAM, so what do? Well, for me, I just buy more RAM. Get a new machine with more RAM. So I'm not going to fill that up, so now I don't have to release any memory. Okay, but historically, as a programmer, especially when you had less memory available to you, we had to be good managers of the resources that we were working with. And now, modern programmers, when they're learning this stuff, they don't even think about it to the point where it's almost something that they never realized existed as a problem, right? If you've only learned Python or you've only learned Java, you've never actually had to deal with the memory issue. I created this object. I'm now done using this object. Somebody better clean up this mess because it's not going to be me. It's not my job. It's beneath me. Something like that, right? All right. It's something that's more made for somebody who's willing to crawl around in your car with a garbage bag and throw everything in it and then go and throw it away. I mean, that's the type of person that would do that kind of work, V.
Wow.
Okay, but if we had a language like C as our first programming language, you're going to be thrown into the deep end. You start creating stuff, and you start calling malloc, memory allocate, and you build memory. When you're done with it, you clean it up. Otherwise, nobody else gets to use that memory ever again. Right, until your machine reboots. then it's freed up. So you do enough programming on your computer, over time you're going to run out of RAM because you have all these leftover arrays. Right? Even when you're writing your software. The good news for us, modern operating systems do some cleanup for us. They kind of run programs inside their own little pods, and they'll release memory associated with that. But if we go back to an older base operating system that didn't have our back, let's say, we would have had a situation where if you work on your program for 3 or 4 hours and you're something with arrays, and during that 3 or 4 hours, you've generated, 300 arrays, right? And each one had, 100 buckets in it or something like that. Now you have 300 100 bucket int arrays sitting out there in memory that's not going to be given back until you restart your computer. So a 100 bucket int array is 400 bytes, right? So now we have, 12,000 bytes of memory that we've used working on your homework that now is not available to the rest of your operating system until the next reboot. That's just from doing your homework once. That's going to start adding up. We see that as a problem, right? At least potentially, especially in the older days when we didn't have 16 or 32 gigs of RAM, right? You had 8 megabytes of RAM, 4 megabytes of RAM, 1 megabyte of RAM. That was considered a lot of RAM once upon a time. 32 kilobytes of RAM. Okay, so if you have 12,000 bytes divided by 1,024, that is 11.7 kilobytes. That's a third of the total system memory in a computer that Bill Gates once said you'll never need more than 32K of RAM from working on your homework once. You've literally burned a third of your RAM, never to be brought back until you restart the OS. So the importance of creating memory, which is a requirement to store stuff, but then cleaning it up historically, it was mandatory. Today, we don't have to think about it. But if you learn programming in a language like C, is your first language, or C++, if you want to approach it from an object-oriented perspective, now you gain the benefit, I'll call it a benefit from a computer science perspective, of having to think like an old school programmer. Because those things are still important today situationally, because C is still used in embedded systems, as Luke pointed out, and embedded systems look a lot like the computers that we had a long time ago. The embedded circuit board that's running your dishwasher doesn't have 8 gigs of RAM, right? It doesn't have a 8-core processor. You know, the resources that you're working with that thing are small. So you got to be you got to be careful what you're doing. So the people who go into programming for embedded systems, they're using C for a similar reason, like you pointed out. There's less stuff hidden, but they also, I think we can look at that same statement from the other side and say the programmer has more control. They don't have to rely on the language to clean up their mess, because garbage collection takes resources. That's another computer program that's running on that processor, and the processor that's running on that dishwasher, not a Core i9, not running, 6, 8 cores, whatever. It's a 200 megahertz bought in bulk from some small CPU manufacturer that's wherever, but that's creating, that's not a general purpose processor. It's a processor that knows how to do these 11 things, something like that. There's 11 magic tricks on it. Okay, this guy's not ready for to play your latest greatest video game. He doesn't have the horsepower. He's not bringing that to the table.
If you overclock your dishwasher, will it wash your dishes faster?
It will increase the or decrease the amount of time until you get your next dishwasher.
So yes.
All right. So we kind of ended last time with this idea of Swift. So this kind of goes our other direction. When we talk about, and really the best way to show this is if we are in a language like, here we'll go a couple of directions. So let's say we're doing a C++ object, and I'm going to purposely use malloc instead of, this is okay. I'm going to do it with object. So I'm going to fudge the C++ syntax just a little bit to drive the point home. So let's say in C++ we're creating a person object. So we'll have a person pointer P, and this guy is going to be equal to, we first need to give him some memory. So this is where I'm kind of fudging it a little bit because you actually would use the new keyword and stuff. But I'm going to say we're going to, actually, you know what? We're going to use the ObjectiveC syntax. That'll allow me to do what I want to do. So the ObjectiveC syntax would be alloc person init with fname. Actually, if we're going to be complete, so that might be how we create a instance of person in ObjectiveC. So we're allocating some memory. How much memory? Enough for this person, calling this as their constructor, init with first name. This is a NSString in ObjectiveC, next step string. Remember the old story I've told in one of your classes about how Apple today actually is not Apple from the 90s or early 2000s. It's Next computers that came with, that Apple acquired, that brought Steve Jobs back to the company, and now they just threw an Apple logo on top of it. So that's an NS string. That's why it has a little ampersand before it to flag it as a better string than the built-in string. All right, so that's my constructor for it. So this would be an example of creating an object in Objective-C. So we're specifically allocating memory and calling this constructor. Make sense? All right. So now, if we go to a language like Java, we would say person, P, is equal to new person like Lippmann. So what have we dropped between these two? Well, we can really call this the same lineage as C++. All right, so these are the This is the evolutionary chain for these guys, right? Right, so what did we drop between Java or C/Objective-C, well, C++/Objective-C and Java? Well, we dropped the syntax for saying this guy is a pointer type. This is a variable capable of holding a memory address. And we also dropped, the explicit thing that looks like memory allocation. We just replaced it with a friendlier looking new keyword. Right? Okay. So now, here's our C#. So this is Objective-C. This is Java. This guy is C#. So now we get to Swift. So Swift, we're going to say var p is equal to person.
What was that?
You don't actually even need the semicolon. Something like that. And if you want to throw, here, we'll throw another guy in here. Here's Python. And this guy is Swift. So what have we seen over the years? So Python being an interpreted language, that's why we don't have a type. It's a loosely typed language. There's not a type before it. With Swift, I can put a type before it if I'd like, but I don't have to. I can let it infer the type. The first time the variable is used, it infers the type, and then from that point forward, it's that type. So you don't have the flexibility of saying, okay, well, I'll put a person in my variable p, but in 20 minutes, I'm going to put an ice cream cone in there. Can't do that. Once it becomes its thing, once it gets labeled, that's what he is from that point forward. So it is a strongly typed language. He just looks like a loosely typed language when you're writing it. Why do you think that is? Who is Swift trying to appeal to? Swift is whose language? Apple's language. What was the language that came before Swift?
Objective-C.
This guy. So this is the language that presumably Swift is upgrading. Now, how many of you would want to write in this language? It's actually among my favorite languages, even today. I really, really, really like the idea of how things are spelled out. I mean, this almost reads like a sentence. Init with first name Mike and last name Littman. Once you get used to the weird square bracket syntax, you realize that it's exactly the same as anything else. I probably prefer Objective-C over most languages.
It seems a little verbose. There's a lot going on.
No, you're right. You're right. But sometimes I would almost say necessarily, where if you look at this thing here, I can make a guess what this first parameter and the second parameter is, but might not be a great guess. Make sense? But we can say that at the very least, we can ask this question. Were the people writing Apple software complaining about Objective-C? No, they're drinking the Kool-Aid. They're fine with it. It's good. In fact, it's what made them unique. It's like, well, we're Objective-C programmers. Nobody else has the guts to learn Objective-C. So they stay in that Apple ecosystem. They're not complaining. So who is Swift for? Go ahead.
People getting into iOS development that didn't know it before. So like they're trying to pull in new people.
Okay.
Android programmers?
Android programmers, Python programmers, everybody else. Come over to the dark side. Because now our language looks like insert your favorite language. Swift has loops that match up to like every kind of weird loop that you have in any language. They've tried to be everything to everyone. So I think their own demise. At this point what's happened is Swift they started off with this everything approach. And now that they have maybe their initial push to get the people to kind of jump over to the dark side, now what they can do is they're starting to, as they update Swift. They're pulling out certain features that were there day one to maybe make it a little bit more of a structured language. They did leave the emojis in for variable names though. So you can actually use emojis for variable names, which is messed up. But in any case, we see that if we look at Java or C#, the new keyword is required here. But this constructor always returns a memory address. So we see in Swift, that's no longer there. We don't have a new or an alec or a malloc or any sort of give me new memory keyword. Makes some sense. We might ask, well, if Java took away the pointer syntax here, right? So in C++, we had a pointer syntax, and then we had an explicit allocate symbol or allocate keyword, right? So we're really verbosely saying, look, I'm creating a bucket for holding a memory address, and I am generating a memory address. Those two line up, right? Then in Java, we're saying, look, here's a friendly looking variable, just like any other variable. And oh, by the way, I'm creating a memory address. Why did we only go halfway there? We're down here in Swift, we said, look, here's a friendly variable, just like any other variable, and here's my constructor. And it's going to return a nice friendly value. Whatever that is. We don't have to worry about it. That makes sense? So we're seeing the language evolution over time. And one of the things that hopefully we kind of got out of looking at C is that a language that's friendlier for the programmer doesn't necessarily mean it's better for the programmer. I would probably make the argument that a friendlier language is better for an advanced programmer. Quality of life is better. Why have to do some extra things if you don't need to? If you've been driving a car for 25 years, let's say, and you're already very well, it doesn't take 25 years, but let's say you've been driving a car for 5 years. You're already a skilled car driver. You are comfortable and stuff. Are you okay having cruise control and automatic windows? And those are things you appreciate, right? Until you get the rental car that doesn't have the backup camera, and you don't actually know how to back up without the backup camera. Because that's one thing. You get your car at home, as we keep, as tech people, we like to get all the tech that we can afford, right? Then you go and rent a car somewhere and it has no tech in it. And all of a sudden you no longer have the flexibility to look behind you, right? Remember you have the blind spot sensors too, right? Any of you have the blind spot sensors in your car? Where if I just turn on your turn signal, I don't have to check my mirror or anything. I just look at the little dot. It tells me whether somebody's over there. The Tesla, you just turn on your turn signal and it just switches lanes for you. I'll do it when I can. Okay, now you've just forgotten how to drive, right? You're relying on this tool. Now you're in some rental car in Mexico that doesn't even, you got to get out front and crank in the to turn the thing on. My grandpa, when he was still alive, this was after he should have stopped driving, but before he did stop driving. There's a transition period there when you get very elderly and you finally convince yourself you should no longer be on the road. He was legally blind. And he's driving. So he couldn't see with these mirrors or anything. So what he would do is he would slowly kind of slightly merge into the lane next to him and just listen for the honks. And once he was convinced he was clear, he would go over. True story. Okay, so let's talk about the exam. I'm going to make the exam online again, just like it was before. Mostly because, obviously, we have the Ann Arbor folks. The scheduled time for the exam is, I think it's Wednesday, right? Is Wednesday at 10:10 a.m. Central Time. I say that because Ann Arbor is not on Central Time. All right. I need you to have the exam in by midnight on Friday of finals week. That's when I need it from you by. I will make a point to be here on campus and active on Slack and all those things at 10 a.m. Central on Wednesday. I'll probably be online or available at other times as well. But if you want to make sure you have access to ask real-time questions and things like that, I will be online, guaranteed paying attention at that period of time. Okay? I am not going to put a time limit on the exam, which means that I'm going to make the exam take somewhere between 12 and 18 hours. Of course, I completely assume on question 3 you'll let me know you have a work emergency.
Yes, well, if there's no time limit, then it'll be okay.
Yeah, I gotta go. That was like the best exam answer I've ever had. He's just cruising along. I gotta go.
Did you at least get full credit for that answer?
I almost did, actually. I didn't, just from an ethical perspective, but I was close. You just don't get a better answer than that.
Hang on,
I gotta-
literally type.
He wrote as his answer, I gotta go. I got a call from work, have to go. Submitting test now. Hey, you gotta respect that. You gotta respect his honesty, right? All right. So it'll be online. The usual 10 questions.
Hang on, are you gonna open it on Monday, or are you gonna open it on?
I'll open it as soon as I write it. So I'm hoping I have it written either today or tomorrow. So it's possible you could do it over the weekend if you wanted to, but I don't want to promise the time. It'll definitely be available by the beginning of the day on Monday. But my intention is to have it done today or tomorrow. That's my intention. All right, so 10 questions, all short answer programming, so no multiple choice, no fill in the blank. Close notes, close neighbor, your mind only. All right, I want to see what you have learned in here. It is cumulative, so covering everything from the beginning, but emphasis will be put on the things since the midterm. If I were you and I was studying for this, I would go back to the midterm and look at the questions that, if you look at our solution from the midterm, look at the questions that I mentioned were often missed. Those might be ones that I choose to ask again, probably not the identical question, but in a similar format. I almost always have a conversion question on my exam, so make sure you can convert all the number bases to and from, so decimal to whatever, octal to hex, whatever I ask you to do. You should also know how to convert, kilobits to megabytes. Those are all things that all computer science folks should know how to do, and you should be prepared to do it on any sort of exam, even if it's not even related. So you'll have one question ask you to convert something. So you should already know how to do that stuff. It's unrelated to the topics in this course, but it's related to computer science. It'll be on the exam. Make sense? All right, so you should all have learned that by now. So if this isn't something you know, it should be free 10 points. All right? So cumulative, focus on since midterm. Let's see. Any questions? You will have to do it in a single sitting. So even though there isn't a time limit, Blackboard they're going to make you sit and finish it and then submit it. So you don't get to leave for a day and go and think about it and then come back. So when you sit down, the exam is going to be designed to be like an exam I would give in a class and take about an hour. That's what the exam was designed for. So you don't have to mentally prepare for the 6-hour epic, right? But I'm not going to put a time constraint on you. Take your time. Show me what you're capable of. Show me what you're capable of doing. Don't Google stuff. Don't Slack your friends or whatever. Don't work in teams. I want to see what's in your brain. All right, sound good? Questions, comments, concerns, bribes? Good.
So, what would be an example of like the most difficult problem that might be on the exam?
An example of the most difficult problem that potentially can be in the exam? Write an object-oriented interpreter.
I see.
No, I mean, it's going to be, the programming questions will be focused more on your ability to work with recursion and maybe lets for local variables, maybe a let rec. So there'll be a couple of more generalistic programming questions. Then there'll be questions specifically involving language stuff where I might show you some code and say, what does this do? Or I might give you an interpreter and ask you, or give you a bunch of constructors and say, build me the equivalent code in this language for an if statement or something like that, asking if a certain number is greater than 10, that kind of thing. So, I don't know. I think it's a hard question to answer. What's the hardest thing that'll be on there? So, the hardest thing that's on there is just something impossible.
That sort of answers my question.
All right.
So.
Anything else? All right. I will see everybody when I see ya. If you haven't already done so and you have availability in your schedule and you haven't already taken it, strongly, strongly, strongly encourage you to take the 426 class next semester. The 450 class will be available for register here. If the registrar didn't get it put in today, I'm guessing it'll be in early next week. I will not let you take that class if you could take 426 and haven't taken 426. Make sense? So take the security class if you haven't had it and it's available in your, it's going to be a good class. They're going to do penetration testing with Raspberry Pis. They're going to do some legit stuff in there. All right?
When is the 450?